So here we go. Now we're transitioning over to word problems. If I can go back, guys, and look at think of your tests when it comes to functions, I think some of you struggled to kind of picture what is the x-intercept telling me right now in this word problem? Like, what is it? I know that it's the x-intercept, but what is it telling me in this context, right? So I'm going to try to help you out with that a little bit more. So sinusoidal functions are periodic, and so the patterns will repeat, okay? So the height of a seat on a Ferris wheel, the average temperature for a full year, time or depth of ocean tides, etc., okay? The amount of daylight that you have on any given day is periodic. Sinusoidal, this is particularly, guys, this one right here is for wheels, okay? It's really important that you get this one. No, not funny? This is for a wheel, because some students are like, oh yeah, it's always true. It's like, no, this is for a wheel. So when you know that, sometimes a rock is stuck in a wheel, right? It's stuck in the threads and it just keeps going. That's a wheel situation. When you have a Ferris wheel, that's a wheel. If you have a paddle boat, right, that's a wheel. So then you can use this, okay? So I'm just going to highlight this box. I think I'm not going to spend too much time on it because we're going to come across these situations, but amplitude is the radius of the wheel. Diameter, therefore, if the question asks you what's the diameter of the wheel, it's 2 times my amplitude. Period is the amount of units along the x-axis for the pattern to repeat. It could be most likely, the time it takes for a mark on the tire to go from the lowest to the highest and then back down to the lowest point. Okay? For a full rotation. And I'm using this visual here. We're going to make this easy on ourselves, even though the story can start anywhere on the wheel, okay, guys? But let's say you make a mark on the wheel at the very top, okay? Would you agree with me that a full cycle would be the circumference of this wheel, right? So if you were to cut this and open it up like lengthwise, it's the circumference of the wheel that would give us a full cycle. Okay? So here's what I want you to understand. This is my starting point, okay? Here we're going to be at a quarter rotation. A quarter. Half, 3/4, back to full. Okay? It's going to take us a full period to get back. Guys, make sure you pay attention for now, okay? And then later we can continue. Right? So what I want you to visualize, maybe I jumped the gun here. I should have maybe prepped this a little bit better. But what we're going to do in this course a lot is we're going to say, okay, well, this is a full cycle right here. I know that over here, I'm expecting to be, for this mark on the tire, if it turns around and this thing moves forward, it's going to go down to the middle, to the lowest point, and then come back up here. If this is a full period, okay, let's go from end to end. If that's a full period, we're going to chunk that up into quarters. Okay, we're going to chunk that up into quarters. So basically what I often tend to do is like, okay, if this is the period, and by the way, it could have just gone up to here, or it could have gone up to there. I just have done this strategically. I want to spread it out to give us space. Then a quarter rotation would get us to here. Right? This thing moves and then it goes here. Another quarter rotation would get us to the lowest point. That's half a cycle right there. And then we would, once you get to the bottom, you have to come back up, right? You'll be here and back up, okay? So in a sense, if you were to graph the height of that mark on the tire over time, you get this full sine wave here, okay? So this is a quarter of a rotation, a quarter period, right? This part right here. This is another quarter of a period. This is another quarter of a period. And the last quarter of the period is, I'm going to actually break this down, slice it up like that. So you have 4 quarters, and that's going to help us come up with 5 points. You ready for this? Count the points from the very beginning. 1, 2, 3, 4, 5. How many points do you think a sinusoidal regression needs to make an equation? 5 points. So we're going to strategically focus on these ones here to come up with the 5 points we need to make the regression, okay? I'm going to skip whatever's at the bottom here because I talked about it. We did it on the AC. I'm going to go straight into the word problem with you guys. I'm actually going to skip a bunch to 21. That used to be a funny number as well. I don't know if you're too old for that already. Is that still a thing? 21? Okay, let's do a regression that I call, this is like the easiest regression you're ever going to have to do because the points are given to you already. Next week, I'm going to ask you to make your own. Mr. Dirksen is going off-roading with his Jeep. He gets to a point on the road where there's 1 foot of water just standing there. The height of a certain point on one of the tires with respect to the water surface has been recorded in the table below. What do we do with this first row? Where does that go into? L1, which is now also my x variable. It never changes. The height goes into L2, which is now my y variable. So every single point on this function will be time and height. Okay, there we go. So let's do that. Let's type this thing in. Way more than 5 points, but that's not a problem for us. I'm going to clear everything. Oops, don't forget the decimal. Type that in. Don't negatives, right? Make sure you don't miss the negative. Take a moment to check your points, please. It doesn't take that long. And it saves you from losing a mark. Usually on the provincial exam, if you get the wrong equation, you lose a mark. Unless I can find out what you did wrong. But I'm going to be honest, I'm not going to check every single value and be like, did you mess up on this one? Did you mess up on this one? Did you miss the decimal? Did you do this? I can't do that, guys. I'll be there forever, okay? So please double check. I'm going to double check. It doesn't take that much time. And I think I'm good, okay? So you go to your paper, you show a little bit of work, stat, calc, and there's some a regression called sinusoidal regression, SINREG. So stat, calc, it's way down there, right there, SINREG, okay? I don't think anybody mistakenly used linear reg instead of natural log reg. So way to go, guys. I think you're the first group where I can say that. SINREG, L1, L2, Y1, just like before. There you go. Write it down. It gives you the general form. Y is equal to 3.03 sine of 3.15 x minus 1.53 plus 1.92. Did I get it right? This is what I got. So I think we're good. It matches my key. If you're not getting this, the first thing you want to check is my calculator set to radians? Number one. Second, check your values. Third, I don't know. Troubleshoot. Okay. Good luck. You're on your own. But the good news is, you get this wrong, everything else, I will now type this into my calculator, and I will follow your tracks. Okay? If it's accurate, if it's consistent, you get the marks. Okay? So don't despair. So let's graph this thing now. Hold on. I would like you to know the basics. My max, let's do this real quick, 3.03 plus 1.92. The max is 4.95-ish. The min is 1.92 minus 3.03. It's negative 1.11. This will be a little different from your equation because we're using all decimals in our y1, okay? In our y1, we have all decimals in there. So let's go ahead and change our window first. Oh, what's the period? Let's figure that out too. 2 pi divided by 3.15. I'll figure that out. 2 pi divided by 3.15. Is it 3.15? Did I miss? Yeah, it is. This will be 1.99. I should have rounded. I am into lately I've been rounding this to 4 decimals because when you round this to 4 decimals, most of the time your period ends up being a whole number. I chose to go with 2, nothing wrong with it, but in this case, your period here for us is 1.99, as long as you know that. You wouldn't lose marks either way, okay? So that helps me for my window, right? Because my window, do I have negative x's? I don't have negative time, right? So I'm gonna go -2 there. X max, I'm gonna go 3 or 4 of those, right? So 3 times 2 basically for my X max. My Y min, I'm gonna go -2 maybe. And my Y max, I'm gonna go 5. I'm basing it on this little inventory here. Hit graph. It's a pretty good graph. You can see everything. Okay. We'll figure it out later if there's something not working out. Okay. Remember you used L1 and L2. If you want to see your points, turn on plot 1 and then hit graph again. Those points are actually showing up there. So if you want that, I don't really want it, so I'm going to turn it off. I think we're good. All right, so let's answer some questions now. Hold on, I'm going to pause here. Okay, so change to x meant to negative. I graph it again. There we go. So now we can answer questions, okay? Now it's basically what we've been doing in the other functions. This one just behaves differently, that's all. For how long does it take for the tire to complete a full revolution? What is it asking for? What is a full revolution? So what is it asking for out of all the things we've learned about? Is it asking for the max, the min, the period, the amplitude? Actually asking for the period. Yes. Asking for period. Okay? It's asking you if you know the highest and you go to the lowest and back to the highest, it's asking for this. Okay? Looks like a smiley face. Okay? You can probably do a cartoon out of that one. Or like a frog, a king frog, I don't know. So this is what we're asking. We already found that actually, guys. We found that. So because we have our equation, we can just go period is 2 pi divided by 3.15. We already know that it's 1.99. What are my units in when I look at the x values? Go to your x variables. It's in seconds. And it does say how long, right? Like how long does it take? It's time, right? 1.99 seconds. If you want to nerd out, you can take that. I'll just mark it as, yeah. Then you have the answer key. You can't get it. No. I wanted to. I trust you got it. Okay. Now I lost my train of thought. Oh, okay. If you want to nerd out and you want to like do more decimals, then obviously your period would have been probably 2 exactly, and that you're not a nerd. You're good. Okay. I don't want to call names here. But then you got 2 here. You just got to go off of whatever your equation, whatever you chose to do with your equation. That's fine. I need you to understand this though. Is there a different way to find the period? Could we find the x value here and the x value there and subtract them? Way too much work. But you could have. You could have. You probably, if you showed me the work, would have gotten exactly 2. Most likely, because your calculator is using all decimals, right? So you go second trace max. If you find that one, and that one, like that would be 2.98. I'm just going to write it down, 17. And then I'll find another max. .9772. If I subtract those, okay, 4.9772 minus 2.9817. Yeah, that rounds to 2 right? That would be 2, because that 5 bumps that to a 0, 0, 2, except for you would have to answer like this. Okay? So if you did it this way, that's fine. Just show your work. That's all I'm asking. Just show your work. I think I overkilled this question, I know, but I need you to understand that sometimes you might be stuck and you're like, well, I can't do it, right? Like, yes, you have tools. Use what you have available to help you out with that. What is the lowest and the highest point the tire achieves? What is the lowest? Yeah, negative 1.11 what? We are y variable, feet, right? Highest is 4.95 feet. What does the negative represent in this case? The mark on the tire goes underwater, right? Under that 0 level. Okay? A negative value indicates, what is it talking about? A point? Yeah, the tire goes underwater. underwater. Okay. The next one we won't do because we haven't done conversions and all of that yet. Going from feet to meters, kilometers. We'll do that on the very last unit. So just for now, this would be omit. It'd be a bonus for now. Okay? All right. I want you to go to 23. And work all the way to at least 27. That's way too much? I don't think so. We're so close to the end. Give that a try. Okay, listen to this part. I'll make a deal with you for now. If it says graph this, maybe don't for now. I'm okay with you not graphing it. Just answer the questions. Just answer the questions. Make a little sketch, but don't do a clean graph. I will show you how to do that on Tuesday. However, listen to this part. If you want to graph, remember I told you to start at a max or a min and then go from there? Do you remember that trick? So let's say you find, Sean and Ryle, just for now, just pay attention. Let's say you find this and then you add a period. And then you add a period, right, to get those. You find a min, you add a period, and then you go like this, right? It's still true, but in this case, because it's a word problem, we want to find the, what do we call this? The y-intercept. So we want to include that in our graph. If you're going to graph, that's what you want to include. So you can do what we did before, but you do want to include the y-intercept, like the starting point. So that's the one extra layer if you want to practice already on how to graph. And just make sure you have labels and all of that as well. Okay, I'm going to stop so you have a good 20 minutes.